Our question is we are given an array and which is of length n, and there are n vertical lines there. These are represented by I, and we have to return the what are the maximum number of amount of water this whole container can store. There is one test case there. Like say, let's copy this. Um, and corresponding to this the answer should be 49. So how is this 49? Let's say if we enclose our water between this height and this height, since if we plot this in the diagram, if we do this in the diagram flow, so we see one thing that water is at maximum whenever we take our left as this 8 height and the right is at 7 height. So our water is go up to maximum 7 height, and what is the width of this container become? So it is 1 2 3 4 5 6 7. So this is 7. So basically it is 7 into 7. So this is the maximum answer this, and you can check all of the area according to all of the pairs. So this is the maximum answer. So first of all, the first thing that comes to my mind is let's check for the each of the pair, like what I'm saying. Let's say we can use 2 pointers there. We fix our I is there and j is starting from I plus 1 and it goes to the end of the array. Then we increasing I, then j is from I plus 1 to end, then I increasing, then j is from I plus 1 to end. So simply we can see corresponding to each of the pairs we have to calculate that how much of the maximum area possible. That is our answer. So but there's a issue. What is the issue there? If we use brute, so it takes our of n square time complexity, but since in the question it is given that constraint is the size is 10 power 4, so size is 10 power 5, so that gives TLA for the of n square because it is greater than 10 power 7. So we should go for the optimal answer. So we see one thing there, like in the brute force, how we simply failed in this 2 pointer approach, because we starting from the start I, and then we go for the its adjacent, and like simply traditionally we traverse along the array and check for each of the corresponding pairs. Now let's say we have to simply optimal our this brute force. So now we also again use the 2 pointer approach, but now we can use one thing there, like we initialize our I in this starting, and we can initialize our j vector at the ending pointer. Like now how we decide these things? So first of all, the concept behind this, like we can simply say this. Let's say we have two height here. Let's say at ith position we have our height, that is, let's say hi, and let's say at our jth position our height is hj. So we can say one thing: the height of the water that is enclosed in this container with its wall hi and hj is the minimum height of hi and hj. Like we can say we are guaranteed that let's say we can take the height as a 3 and another height is a 6. So we can say one thing: the maximum height of the water enclosed in this container is up to 3. So we are sure about one thing, that our height is the minimum of left side and right side. So that is hi and hj. Similarly, the width of this container is simply j minus I. We can say one thing. Let's say we have to enclose our water between this 8 and 6. So how we judge so how the water is enclosed in this? So the water that is placed in this container with its left height is 8 and right height is 6. So the height of the water rising is 6 and the width is simply 1. So we can say one thing that we have to like simply check uh, for each of the I and j, we like initialize our I at the starting and j at the ending, and we simply is starting out the loop as while I less than equal to j. Like our I pointer goes to forward and j pointer goes to backward, and when they meet means stop at there, and till now till then whatever the maximum area is our resultant area. So, and one thing is there, like we have to maximize the array, and array is basically height into width, so we have to maximize this product. So how we can maximize this product, like if we shrink, let if I pointer goes to forward and j pointer goes to backward, so width is decreasing. So if width is decreasing, so we have to do such operations so that our height is increasing and this part is dominated such that overall product is increasing. That's why our area becomes so more increasing, area becomes larger. So we say one thing, let's say we incorporated two heights. Let's say this is h1 and this is hi and this is hj, left side and right side. We say one thing, what whoever the height is smallest, we simply move that pointer. Like let's say we have a left side a height of 3. Let's say we have a height of 3 there, and at the right side we have a height of 8. So what it means, like this is for I, this is of I there, and this is of j there. So like how to do this, we simply I plus plus, first of all we calculated for this and ij, and now we have to proceed of I and j, I plus plus. Similarly other there's other condition. Similarly we also do this whenever our right side is smaller than left side, so we move our j pointer to backward, so j minus minus. So that is our, so let's say we initialize our answer equal to 0, and there's a starting as z first of okay, so s equal to z 0 and equal to n minus 1. Now we can say one thing, while our I less than equal to j, or sorry, this is let's say we can rename that as L, this is rename as R, because I'm more comfortable in that naming. So this L means left side and this R is the right side, means this is left side height and this is the right side height. So first of all we calculate for this like ans equal to max of ans, comma, this is min of v of L, comma, v of R, this whole product with the R minus L. Okay, so I think yeah, so for this LR this is our and now what's the condition is, if VL is less than of V of R, so VL plus, else if our VL is greater than V of R, we simply R minus minus, else in the condition if both are equal, so what we simply L plus plus and there R minus minus. So this is our operation, and now we simply return our answer, this is end L. So yeah, so let's say for this test case, so there's this is of height 1 2 3 4 5 6 7 8 9, so this is of 9, and this is of 1 8 6 2 5 4 8 3 7. So let's run this. What's the issue there? Oh, okay, I am naming this vector as a, so we should go for a, yeah, like my means we should go for the v. So run this. Yeah, 49. We can also check for the other test cases. Let's say what's the given in this, this is a 1 and 1, so let's check this. This is of size 2 and this array is 1 and 1. So yeah, this is the output 1, means our code is true. and simply we say one thing, we the time complexity for this optimal, the time complexity is simply of n, and space complexity is of 1. So thank you.